Dr. Angus Gentle works in the Department of Physics and Advanced Materials at UTS. He's designing systems that may one day replace expensive air conditioning and refrigeration. Angus Gentle, thank you for talking to me today. You're looking at paints that can help with cooling. What are they?
So we're looking at paints, coatings and systems that we can put on roofs of buildings so that we can generate coldness that we can then store in liquids, or just pumping the air through the buildings so that we can cool buildings.
So would you say that they're smart paints?
You could say smart paints. Most of our stuff, we would want to use it in more than just a paint. You'd have a whole system around it where you have a coating and heat exchangers.
Can you go into a little bit more detail?
The cooling is based on radiative cooling or night sky cooling, which is similar to your windscreen of a car that gets frost on it on a cold night when other surfaces don't get the frost. So you're pointing up at the sky, emitting at certain wavelengths which the sky doesn't absorb, and so because the sky doesn't absorb at those wavelengths, it doesn't get any heat back from them. So we're optimising our surfaces so that we can pump as much heat out as possible without absorbing heat.
So how does it apply? How would you put it on a surface, for example?
So to put it onto a surface, we're using sputtering, which is a vacuum deposition technique, which is used commercially for coating glass for buildings, architectural ones. So if you've got coloured glasses or reflective coatings on glass for buildings, they're usually done by sputtering.
How cold can you make it?
We're getting down to about 15 degrees below the lowest temperature of the night. So when it's, say, 10 degrees, we'll get to -5 degrees. So we could create ice, which we were doing. We were making ice on the surface of our thing earlier in the year.
That must have been a pretty exciting day. Tell me more about that.
We had these surfaces which had been up on the roof for a little while, and these surfaces are dependent on how much moisture is in the atmosphere. So that depends on how transparent the atmosphere is and how much heat you'd be getting back from it. And it was a nice dry sort of time of the year, and the ambient temperature was quite cool. So we thought these would be quite good times for measuring it. And you're measuring the temperature, even at 5 o'clock in the afternoon, the samples were already at about 1 degrees. And we thought this will be a good night for getting this thing. As it went through 0 degrees, you could see the cooling of the surface slow down as an ice layer formed on the surface, and then it continued to cool down below that.
It's pretty exciting to think how this kind of paint could be used in our everyday lives, isn't it?
Hopefully, once these systems are produced and optimised, we'll be able to put them onto roofs of buildings so that we can collect coolness into, say, a water solution and then pump it through the building to keep the building cool and avoid having to use air conditioners.
So what would this mean for something like air conditioning, and how would this technology compare with it?
Our system would be, you have a large surface on your roof of your house, which is a panel which is facing the sky. Just like solar panels, you don't want it shaded by trees or anything like that. And then it has a heat exchanger in the back of it where you're pumping a fluid through it, which is stored in a large tank, which you'd probably put under the house or beside it so that it's not getting sun onto it to heat it back up. And then you're pumping it through the building to cool it off. There are currently technologies out there where people pump water through buildings on the floor or on the roof to cool them down, but they're using air conditioners at night to cool the water. So we could improve those further by cooling the water radiatively.
So what level of interest have you got from industry?
As with most cool roof paints for keeping things cool during the day, industry is always going to be interested because it'll be ways to minimise the energy that's used by buildings. And so because of that, then you're not having to burn as much coal, because you're not having to use coal for producing air conditioning electricity.
Are there some challenges in attracting the attention of industry?
Currently, the price of electricity is very cheap, but that's going to be going up, and there's a lot more awareness on green issues these days, so people are starting to look at it even as we speak.
How do you go about your research?
Okay, so essentially we start off by doing optical models to see what different coatings how they would perform, what their spectral properties are in visible and thermal wavelengths. And from those optical properties, we then will put them into a computer model which will say how well they'll perform, so how much cooling power we'll get out of it. And if they look good, we'll then deposit them using the sputtering. After we've deposited a film, we'll then characterise it spectrally to make sure it actually performs the same as it was supposed to. Then we'll put the samples outside on the roof and see how well they perform to how much cooling they'll actually do.
What kind of technology do you use?
We use a FTIR, which is a Fourier transform infrared spectrometer, to measure the spectral reflectance of the samples. So then we can see what wavelengths they absorb at and what wavelengths they reflect at. We'll then measure the hemispherical emittance using an emisometer, as well as using a UV visible spectrometer to measure the optical properties in the visible wavelengths, so we can see how they perform in the sun. We'll also measure the thickness of them using a step profilometer, and then take the samples out onto the roof, put them in our test rig to measure the temperature they'll get overnight, then compare them back to the models.
It's obvious that you have to have a lot of attention to detail, but what is it that attracted you to this kind of research?
I've always been interested in different green technologies, and this one's a quite interesting one, which the idea's been around for many years, but hasn't really been picked up on and used. So we're trying to get it out there and make it work.
I imagine it will be a very good day for you when you see your research being applied in people's homes and in our everyday lives.
Yeah, once it gets out onto homes, it'll be quite a good day.